This is a truly unique clock because it has two faces. On this side, you've got Tempus Equale, Greenwich Mean Time. And if I turn it round, on the other side, it's got Tempus Apparens, which is sundial time. All clocks tell Greenwich Mean Time, but Greenwich Mean Time is very difficult to set 400 years ago, 300 years ago, 200 years ago, even 100 years ago. So the only way you could set a clock was by a sundial. The problem with a sundial is that it doesn't give equal time. Because the Earth goes round the Sun in an elliptical orbit rather than a circular one, the length of every day changes and the time of noon changes, up to 15 minutes different between Greenwich Mean Time and a sundial time. A lot of clocks were manufactured and had inside them an equation of time which gave you the difference between Greenwich Mean Time and the sundial time, so that you could set your clock wrong by the sundial but correct by Greenwich Mean Time. So the unique feature of this clock is that you've got Greenwich Mean Time on this side and sundial time on that side. So you don't have to work anything out, you don't have to look up in any table. You can just go into the garden, read what time it is, come and set this side to the sundial, and you've got Greenwich Mean Time on the other side. So on the Tempus Equalis, the equal time of Greenwich Mean Time, you've got the standard hour, minute and second. And then above here, you've got a rotating globular moon, and it shows the age of the moon around the outside. So linked to the moon is the age of the moon and the time of high tide, which you can actually set for your local port. This side shows you the day of the week and the deity. So it's Sunday, and here's Apollo racing away across the sky in his chariot. Clockmakers loved their doggerel Latin, and here we are, Jophessus Williamson Londini Fecit. Most ornaments and clocks are spandrels, and they usually have little cherub boys, but this is different. It's very much a lady. So what a collection of information. Here we have an annual calendar which shows each month and the number of days in the month, and then there's also the zodiac sign at the back, and this is the driving force to alter the difference between Greenwich Mean Time and this side, which is the sundial time. And you've got two shutters which come up and down against the two 12-hour indications to give you the length of the day and the length of the night, which obviously changes in the seasons as it goes up and down. And then you've got a regulation for the dial to bring it to time. And look at the lovely incised background, all fire gilded, three-dimensional star in the casting. On the top right-hand side, you've got the strike silent, which allows you to switch off the striking at night by just turning it round to the silent position. So now it won't strike at night, but again, a beautiful engraved silver dial surrounding the three-dimensional star. On the sundial time, Tempus Apparens, you've got to remember that clock is going round this way, whereas on the other side it's going round that way. So Williamson not only has to make the equation of time, the difference, which is about a quarter of an hour in the February period, but he also has to reverse the rotation of this clock to make the hands go around the correct way. So it's quite a complicated mechanism, said he, is the understatement of the clock. So here you've got the worm drive coming up from the Greenwich Mean Time mechanism, engaging into this toothed wheel here, which goes round once in 365 days. And on the back here is a cam which then gives the equation of time, the difference between Greenwich Mean Time and solar time. And the lever here lifts and lowers the pendulum as the cam rotates. The motion from the roller on the cam is pivoted on this big strong pivot here, and then the mechanism goes down to the differential and the method of lifting and lowering the pendulum. The end of the lever here on its underside has a rack which drives this pinion inside here to create the difference between the solar and Greenwich Mean Time by the movement of the lever backwards and forwards, rotating and adding the correction to get the Greenwich Mean Time on one side and the solar time on the other. And finally, the lever has this pair of cheeks which move up and down on the suspension spring of the pendulum, effectively then increasing the length and decreasing the length as the length of the day changes. And that's the mechanism that makes the pendulum gain and lose and keep in time with the sundial. The arbor that is driven round once a year by the worm drive also drives another cam at the back here, and you can see it lifts and moves the two shutters which show the length of the day.